So in this video, we're going to talk about how to do exponential regressions models using DESMOS. So remember that sometimes we need to use exponential functions to model data. Remember that exponential functions have the form y equals a times b to the x. Remember we can also have functions that use e as the base, and they have the form y equals a times e to the bx. So sometimes when we're looking at scatter plots, the data may have an exponential pattern. In these cases, you may need to use an exponential regression to write an equation that best models the data. So let's look at how to do this in DESMOS. So you're going to start off by clicking the plus sign in the upper left-hand corner and then choosing Table. So let's try practicing with this data set given here. So in X, we're going to do 1, 2, 3, 4, 5. And then in Y, we're going to enter these Y values, 285, 270.75, 257.21, 244.35, and 232.13. So now we're going to tell DESMOS to create an exponential function. So the way to do that is to type y1 is approximately a times b, and then we use the exponent, right? So we do x1, right? So remember, in an exponential equation, we want the variable to be in the exponent. So now under parameters, it'll give us the values that we need in order to write this exponential equation. So you can see the value of a is 300 and the value of b is 0.95. So our exponential function will be y equals 300 times 0.95 to the x. So let's try this example. So it says that Farmer Dan tracked the mouse population on his farm over 6 months. The data he observed are recorded in the following table. Use your calculator to perform a regression for the data. Find the equation of the curve of best fit. So what we're going to do is we're going to clear out everything, and then we're going to click the plus sign, and then in table we're going to enter these values. So for months we have 0, 1, 2, 3, 4, 5, and 6. And then for the number of mice, we have 6, 9, 13, 20, 29, 34, and 52. Okay, so now we're going to tell DESMOS to approximate an exponential function. So we're going to type y1 is approximately a times b to the x1. And let's pick up the parameters we need to write our equation. So our equation is going to be y equals 6.9 times 1.4 to the x. So now let's use this equation to predict the number of mice that will be on Dan's farm 10 months after he began recording the data. So we have y equals 6.9, and then for x, we're going to plug in 10. So if we do this on our calculator, we're going to have, now let's see, 6.9 times 1.4 to the 10th power. And then we hit enter, it tells us about 200 mice, right? So we can say, because we're going to round to the nearest whole number, since we're talking about mice, so he's going to have about 200 mice on his farm 10 months after he started recording. So remember that using your calculator, you can model data using exponential regressions. You can then use these equations to predict future values.